Hello and welcome to section 4-2 with the solutions to numbers 1 through 6. Number 1, it says two numbers add to 251 and the second is 41 bigger than 4 times the first. What are the two numbers? We first note that our variables, what are the two numbers? We've got to have two variables. I'm going to say x and a y. Now let's read it again and see if we can get our equations from it. Two numbers add to 251. So that is x plus y is 251. Good. There's our first equation. We're going to need a second equation because we have two variables. The second, y, is equals 41 bigger than 4 times the first. 41 bigger than 4 times the first number. Now look at what we have. We're here in Happy Math Land where we have equations. We know how to deal with those. This one is going to use substitution because y is already by itself. Look how nice that is. So we have x plus 41 plus 4x equals 251. Do we know how to solve this equation? Yeah, we've got one variable. We're back in chapter 2. This is nice. Combine the x's. We have 5x plus 41 equals 251, and then subtract 41 from both sides and we get 5x equals 210. Divide both sides by 5 and we now have x equals 42. 42 is the first number. We stick 42 back up into either one of these and subtract and we get like 209. Let's try it just to make sure. Stick 42 right back up in here and we get y equals 41 plus 4 times 42. That's 41 plus 4 times 42 is 168. So y is going to equal 209. And just double check, 42 and 209, do they add up to 251? And yes, indeed they do. Excellent. All right, number 2. We'll do this one in a different color so we can keep them separated on our scratch paper over here. Two numbers add to 336, and the first is 126 bigger than 5 times the second. What are the two numbers? Notice again, this is why we're in systems of equations. They're asking us for two numbers as a solution. So let's pick it. This time let's do like A and B. First is A and B is the second. So two numbers add to 336. That gives us A plus B equals 336. And then it says the first, that's A, is 126 bigger than 5 times the second. And we have a system of equations. We know how to solve that. We can do substitution, take that guy and put it right over there. We get 126 plus 5b plus b equals 336. Look at that. That's a nice equation with just one variable. We just slickly got rid of one of them. So we get 126 plus 6b equals 336. Subtract 126 from both sides. We now have 6b equals 2, what is that, 10? Is that right? 210? Alrighty. Divide by 6, and we get b equals 35. Now that gives us just one of the numbers. We now have to stick it back up in here, and it looks like if we stick it in here, we have a plus 35 equals 336. So A equals 301. We could also have stuck it up here and taken 5 times 35, gives us like 175, and then we do 126 plus that and we get 301. So 301 and 35 are our numbers and they fit both of these conditions. That's awesome. Next one, number 3. Let's use that. Two numbers add to 251. 2 times the first minus 3 times the second is 52. Ooh, this is a different kind of a problem. What are the two numbers? You want to go back to x and y? Yeah, let's do an x and a y here. Okay, let's read it and see if we can pull out our equations. Two numbers add to 251. So we get x plus y equals 251. Oh, look, it's just like number 1 over here. And it says 2 times the first minus 3 times the second is 52. What are the two numbers? Wow, look at that one. Well, we now have our system of equations. We know how to solve this. Yeah, sure. We times the top guy by 3 and we'll eliminate the y's. Let's try that. So 3x and 2x give us 5x. 3y and negative 3y go away. 3 times 251. This is 753 plus 52 is 805. Divide by 5 and x equals 161. Now if we plug this back in, right up there, we now have 161 plus y equals 251. Subtract 161 and we get y equals, what is that, 90? Yeah, let's double check that. 90. These two add to 251. If we took 2 times 161, that's 282, and minus 3 of those is 270. Oh, sorry, that'd be 322 minus 2 of those, 3 of those, 270, and we get 52. The two numbers are 161 and 90. Excellent. All right, let's try number 4. Two numbers add to 336. Let's do the a and the b again. We have a plus b equals 336. Okay, when does a 4 times the first, 4 times the first is, so that's an equals, 9 less than 7 times the second. Ooh, dang, I don't like how that's written. Wouldn't it be nice if that b were over here? Wait, we can do that. We are powerful. Subtract 7b from both sides and we have this written down. A plus b equals 336, and 4a minus 7b equals a negative 9. All right, this is a system of equations. We know how to do this. We've got to eliminate one of the variables, like the b, by timesing the top guy by 7. That will make a 7b and a negative 7b. So let's do that. 7 up here. And that gives us 7a plus 4a is 11a. Done kind of quickly. Ooh, I'm going to need my calculator for this one. 336 times 7 minus 9 equals 2343. Okay, and divide by 11. I'm going to bring this guy back up. Divide by 11. And what do we get? 213. I'm glad that came out nice. A is 213. So if A is 213, two numbers add to 336. A is 213. Let's take this and stick it right up in there and see if we can get B. 213 plus B equals 336. B equals, subtract 336 minus 213 is 123. So 123 and 213 are the two answers on that one. Great. Let's move on to number 5. And clear that off. Good. Number 5. I've created a triangular garden. We're in a triangle, so we got to think about what formulas are there. Garden such that the largest side is 8 meters less than twice the smallest, and the medium side is 12 meters larger than the smallest side. If the total perimeter of the garden is 108 meters, what are the lengths of the 3 sides? Here we have our question. Lengths of the 3 sides. We've got a largest and a medium and a small. So I'm going to put an L and an M and an S. So let's write down. We've got 3 variables, so we're going to need 3 equations. Let's see what we have here. I have a triangular garden such that the largest side, L, is 8 meters less than twice the smallest. Let's try to make an S so it doesn't look exactly like a 5. Whatever. Okay, so we have medium is 12 meters larger than the smallest. So that's our equation there. And then the total perimeter. How do we get perimeter of a triangle? And that is, well, the large plus the medium plus the small is 108. So really it looks like this. So there's the small side, there's the medium side, there's the large side. And it says the total perimeter is 108. That's where we got that from. Now, some of you may notice that we could have done, well, the medium is 12 larger than S, and the large is 8 less than twice the smallest. And so really, the L and the M are useless. What you're actually doing in there is saying we're going to use substitution. Put this guy in for M and this guy in for L. And that's exactly right. If you just take this plus this plus this, you end up with Let's write it down. The large side is 2s minus 8. The medium side is 12 plus s, and so we take the large side plus the medium side plus that little small side, 108. So this is something you could have actually done back in chapter 2 without any problem if you just added up those three sides equal to 108. But here you can see how it worked with a system of equations, 3 equations and 3 unknowns. We could have had the large as 2 times the medium minus 3 times the smallest, and anyway, it would have given us all sorts of wonderful problems to do. But here we're able to use substitution, and because we get now a formula that has all s's. Okay, so now simplify. We have 4s plus 4 equals 108. Subtract 4. 4s equals 104. And then divide by 4 and you get s equals 26. So the small side is 26 meters. That's important. Now the medium side is 12 bigger than that, so that's a 38 meters. And then the large side is 2s minus 8. So 2 times 26 is 52. Minus 8 is 44, so 44 meters. So they're 26 meters, 38 meters, and 44. And amazingly, you take 26 plus 38 plus 44, and you get 108. All right, cool. Let's now do number 6. Three types of bears are in a national park. The number of grizzly bears is 4 more than twice the number of black bears. Whoa. And the number of panda bears is 50 more than the number of black bears. There are a total of 874 bears in the park. How many of each kind? So this tells us what our variables are. We need grizzly bears, we need black bears, and we need panda bears. There's a G, a B, and a P right there. G, B, P. So let's read through it one more time and see if we can find our 3 equations. So the number of grizzly bears, that's G, is 4 more than twice the number of black bears. Good, that's one equation. Second equation, panda bears is 50 more than the number of black bears. Good. And there are a total of 874. That's grizzly plus black plus panda is 874. Hey, look at this, substitution again. This 50 plus b is going to go in for p, and that 4 plus 2b can go right in there for g. So we have 4 plus 2b plus the number of black bears plus the number of panda, which is 50 plus the black, is 874. Excellent. Nobody really asks the question, what is a grizzly bear and a panda bear doing in the same national park? That is beyond the scope of this question. Don't worry about it. So we have 2, 3, 4b plus 44 and 50 is 54. That's 874. Good. So we have 4b equals 820, subtracting 54 from both sides, and we get b equals 205. Good. 205 is the number of black. So if we put that back up in here, we get 4 plus 2 times 205 equals, that's 410. 4 plus 410 is 414. So the number of grizzly bears is 414. And the number of panda bears then is 50 plus 205. So 255. Okay, so we have 255 panda, 414 grizzly, and 205 black bears. Excellent.